Hey everyone, today I'm going to show you how you can measure the speed of light, not in a lab, but in your kitchen. Let's find out how. Hey there again. Did you know that light travels at a whopping speed of 300 million meters per second? Now that is fast. How fast? Well, if you were to be traveling at that speed, you will be able to go around the Earth about 7 times in 1 second. That fast. Have you ever wondered what light is? Well, when physicists refer to light, what they actually mean is some form of electromagnetic wave. And a bunch of these electromagnetic waves make what is called as the electromagnetic spectrum. Now, at one end of this electromagnetic spectrum, we have what are called as radio waves, which have the longest wavelength and the lowest energy. And at the other end of the spectrum, we have what are called as gamma rays, which have the shortest wavelengths but the highest energy. And in between these two extremes, we have a whole lot of other electromagnetic waves, such as X-rays, UV light, visible light, which is what the human eye is able to perceive, infrared waves, and finally, microwaves. Does that ring any bell? Well, if you ever wondered why a microwave in the kitchen is called a microwave, it's because it uses microwaves to cook your food. Now, the interesting thing about electromagnetic waves is that they all travel at the same constant speed in vacuum, which is about 300 million meters per second, or the speed of light. Now, you may be wondering, why this specific number and why should it be a constant? It turns out that this specific value for the speed of light pops out from a set of equations that was formulated by the famous physicist and mathematician James Clerk Maxwell, which describes some fundamental characteristics about the electromagnetic waves. And then Einstein came along with this special theory of relativity, which says that not only does light travel at this speed, but is also a universal constant, and that nothing can travel faster than the speed of light. Great! Now that we've learned a little bit about light, let's go ahead and do our experiment to measure the speed of light. Now let's take a look at what instruments we need to perform this experiment. You need your microwave, a bar of chocolate, and a standard ruler. The first thing we need to do is to remove the turntable. Now that we have removed the turntable, we are ready to put in the chocolates into the microwave. And what we do then next is to put the chocolate bar on the turntable that comes with the microwave. Put this into the microwave. We place it into the microwave, close the microwave, and I'll put it for a time of 30 seconds. While your microwave is running, let me quickly explain to you how your microwave heats up the food and also what you expect to see in the chocolate bar. The way your microwave works is by forming standing waves inside of it. What does this mean? Let's take the whiteboard to explain this one, shall we? Now imagine this is a microwave. So what happens is that microwaves are generated from one end of the microwave oven, which travel to the other wall, get reflected and traverse back to the other side, thereby forming a pattern which is called as the standing wave pattern. It's called a standing wave pattern because the waves appear to be stationary and not moving. Now, there are certain points in the standing wave where much of the vibration happens. The points corresponding to these blue lines here are called antinodes, and the red points here are called nodes. At the antinodes, where most of the vibrations happen, is where your food will get hot. And at the nodes, where not much vibration happens, your food will remain cold. And that is why all your microwaves, or most microwaves, come with turntables which uniformly distribute the heat. The reason why we need our chocolate bar to be stationary is because we want to observe these points here where most of the heating happens and where our chocolate is expected to be molten. The distance between two antinodes, or the molten hotspots on the chocolate bar, is equal to half the wavelength of the microwave. What we need is the full wavelength, so we multiply that number by a factor of 2. So the speed of light can be computed using this very simple formula. where you have the wavelength, which you can measure by measuring the distance between the molten points on the chocolate bar and multiplying that by 2. And for the other piece of information, which is the frequency, you can find that information at the sticker behind your microwave. In our case, we find the frequency to be 2450 megahertz. Now, using these two pieces of information, we can compute the speed of light. Now let's go check what's happened with the chocolates, shall we? And here's our chocolate. What we see are two spots. One is really charred, and the other one here, which is a cute dimple. Now what we have to do is measure approximately the distance between these 2 points from center to center. So let's do that. So that gives us half the wavelength. And so by multiplying that by 2, we get the full wavelength. So let me write that down here. We have 8 centimeters was what we measured between the two hotspots. And we'll have to multiply that by 2, which will give you the full wavelength in units of centimeters. And we multiply that by the frequency. Now if you do the maths, what you will get is a value that's approximately equal to 3.9 into 10 to the power 8 meters per second. But as I mentioned to you earlier, the speed of light is about 300 million meters per second, which is equal to 3 into 10 to the power 8 meters per second. But the value that we measure with this experiment is somewhat higher. And that is still okay, because we do not have any sophisticated instruments to actually measure this. So it still works out. And there you have it. We have actually measured the speed of light in our kitchen. So why don't you go try it in your kitchen and see what values you find. Have fun sciencing.
Astro 3D is the Australian Research Council's Centre of Excellence for all-sky astrophysics in 3 dimensions. Our astronomers are searching to understand the evolution of the matter, light and elements from the Big Bang to the present day. This Astro in the Home series is your opportunity to unlock the secrets of the universe with your own 2 hands. Find out more by visiting our website, following us on social media, or subscribing to our YouTube channel to be notified whenever we upload new content. Now, go explore the universe.